Now we're working on the independent sample t-test. It compares the means of two independent groups, which we'll talk about later, in order to determine whether there is a statistical evidence that the associated population means are significantly different. So now we need an understanding of what is an independent group. An independent group is basically two variables that are independent from each other. Here are some examples: male, female, and yes and no. The test, the independent sample t-test. Remember last week, the test that was run was on a variable of final weight of a fitness challenge. And we looked at that one variable, that one sample t-test. Now this week, we're going to be using the same variable, final weight of a fitness challenge, and the demographic of gender, male, female, independent groups. So what are we examining? We're examining the difference in the means. So in this case, we're looking at the difference between male and female, and we're analyzing that. So it's the final weight. What did the men have and what did the women have? Who was better, who was higher, who was lower? It depends on what the actual test and what you're actually trying to find out. So now let's get into the data. This is the first box. You'll see that it has male and female and other stuff. I'm going to go over that in a second. So you'll see the first thing is the variable. Now basically there are two variables here. It is total weight or final weight and gender, broken down to male and female. But there's two variables we're looking at. Those are the ones that come right from your demographic survey and then from your survey itself. Okay, so the variable here is final weight that we're actually looking at. The next one up is gender, which is your male and female, and you can see that right there. Now, the next one up is your number of participants. You'll see the arrow goes to 9 and 7, and 9 and 7 equals 16. So there's 16 total participants. Okay. Now the next one up is the mean, and the mean is 215.67 for the male and 157.71 for the female. And you can see the standard deviation, and the standard deviation is male 18.808, and the female is 12.93. So we can kind of look at this and go that they're not really spread out numbers, but they're not totally close either. The Levene's test for equality of means really looks at two different things: where the equal or variance is assumed or were they not assumed. And this is all done through a p-value. If the p-value for the Levene's test on the independent sample data says greater than 0.05, then the variances are not significantly different from each other. The homogeneous assumption of a variance is met, which means we would take equal variances assumed. If the p-value is less than, there is a significant difference, which means the Levene's test for the homogeneous variance is not met, and we would take the equal variance is not assumed. Now a quick refresher from week 2 or week 3. A variance estimates how far apart a set of numbers, random, are spread out from the mean value. Again, this is how far they are from that mean value, whatever that mean value is. Now, in the second part of the process is Levene's test. And you can see the yellow box there with the arrow pointing to it. That's where you start. And then we look at the F value. The F value is F, capital F, it's in italics, equals 0.711. The sig value, the P, which is our main component here, is P equals 0.41. So now the question is the P value above or below 0.05? Well, it is above at P equals 0.41. It is well above 0.05. Since the P value is above 0.05, we use the equal variance as assumed, which is in that yellow box there, it's the top line. And since the P value is above 0.05, we would use the equal variance as assumed, which is the top line right here. Since we're using the equal variance assumed line, because the significance, the p-value of the Levene's test was over 0.05, we need to now get the top box, which is the one marked in yellow. We need the t-value statement. T open parentheses, df, close parentheses, space equals, space t-value, comma, p equals the p-value. And you can see the lines go to the numbers of t with a df of 14 equals 7.15, comma, p equals 0.01. To think simple. So looking at the final weight of a weight competition, weight loss competition, and you don't have all the data here, but I can tell you that it's the final weight of a competition. And in this case, we don't know how much weight they lost, but we do know their actual weights. So in this case, very simply, we look at the two means, the 215.67 and the 157.71, and we created an extremely simple answer for that the male's final weight was higher than the female's. That's it. You're not to delve into anything else or go any deeper. It's what it is as you're looking at the numbers. So putting it all together into the write-up, here's your introductory sentence: to investigate participants' perceptions on the final weight in a weight loss challenge and independent samples t-test was calculated. In this case, the next line is the results analysis showed a significant difference in the final weight in a weight loss challenge. And we looked at the p-value. It is significant difference. Now the next line is our t-value line. Results of the analysis showed a significant difference in choking. T, no space, 14 the percent parentheses, equals 7.15, comma, P equals 0.01, period. And you notice the T and the P are in italics. Now we are doing the mean and standard deviation line. Okay? That mean and standard deviation line, there was a significant difference between the final weights of male and female participants, comma, male, in parentheses, the mean and the standard deviation. M and the SD are both italicized for both the male and the females. And then equals has space between them on both, and then the actual numbers. That's the end of that sentence. Therefore, meaning it's the concluding statement, male's final weight was higher than female's final weight.